Hello, I am Marcelo Kuraica. I'm going to present the research I did with my classmate Sebastian Bobadilla in the class of Energy and Transformation 2, and it is about the influence of blue light in sleep. Generation Z, born between 1997 and 2012, has been surrounded by technology since they were born. As time passes, technology is more involved in their development through education, leisure, entertainment, and sports. Using technology so often leads to a high exposure to blue light. Exposure to blue light has several effects, such as making someone aware and active. This effect could alter a moment where being aware and active is not needed, in particular sleeping. This study will show the relationship between exposure to blue light and sleep quality, in order to create awareness for people of just how much the exposure to blue light affects the sleep cycle. This research will help society by informing how to improve their sleep quality and how to appropriately expose to blue light. Our eyes are constantly exposed to several types of lights inside the light spectrum throughout the day: red, orange, yellow, green, blue, indigo, violet. Most of it from screens, with all of them having different wavelengths. The screens you spend hours in front of emit a very special type of light, blue light. Firstly, a description is provided, then a discussion about the issues the blue light can bring, finally, an explanation of why this research is done. Blue is a color in the visible light spectrum that can be seen by human eyes. Blue light is a short wavelength, which means it produces higher amounts of energy. It is mostly found on screens, our phones, computers, tablets, television, etc. Almost all visible blue light passes through the cornea and lens and reaches the retina. This light may affect vision and could prematurely age the eyes. Interventions to reduce short wavelength light exposure to the eyes before bedtime may help mitigate adverse effects of light emitting electronic devices on sleep. Circadian rhythms are 24-hour cycles that are part of the body's internal clock, running in the background to carry out essential functions and processes. One of the most important and well-known circadian rhythms is the sleep-wake cycle. In other words, a sleep cycle is a daily cycle of being asleep and awake. The optimal hours of sleep may vary between age groups. Teenagers need 8 to 10 hours, whilst adults need 7 to 9 hours of daily sleep. This blue light can help your sleep cycle if it's managed properly, but it can completely corrupt it if it is not. When light strikes the retina, it stimulates melanopsin-based, intrinsically photosensitive retinal ganglion cells, which are known as iPRGCs, that are uniquely sensitive to wavelengths in the blue range of the light spectrum. These iPRGCs project extensively via the retinohypometallic tract to the SCN, which in turn suppresses the production of melatonin by the pineal gland. Thus, exposure to blue wavelength light in the morning suppresses melatonin and phase advances in the circadian rhythm. It is known that this light can be beneficial during the daytime, since it makes us be more alert and practically helps us be awake. It also regulates the circadian rhythm. Too much exposure to it can disturb this wake and sleep cycle, as well as continued exposure to it during nighttime will not allow you to sleep. In a worst case scenario, excessive exposure to blue light can lead to digital eye strain. Symptoms such as eye strain, headaches, and dry eyes caused by watching a screen with poor or dark lighting in front of a screen at close distance. And retina damage, which is damage in the retina. Exposure to blue light is considered excessive when it affects negatively your sleep cycle or causes digital eye strain or retina damage. There are ways to protect yourself from this exposure, but they will not be applied in this research because the goal is to find the direct relation between the continued exposure to this blue light and the sleep cycle. The use of screens is a necessity in times like this, where everything is done behind the screen, and it is clearly not good for the health. Thus, this research will find the relationship between exposure to blue light and the sleep cycle and how much it affects it. There was a method to follow for this. Our hypothesis was that the less hours spent exposed to blue light, the more hours of sleep there will be. Our main variables were hours of sleep was our dependent variable, hours spent in front of the screen was our independent variable, age, students, electronic devices, daily activities, etc., were our control variables. The experimental design, it was conducted in with 10 volunteer test subjects. They were all between the ages from 16 to 18 years old. Subjects had to report the daily data via message with help of some materials. Our materials, their materials were an iPhone with the screen time feature and an Apple Watch with the sleep tracking feature. Our method was in order to prove our hypothesis, we asked volunteers to be part of it. Each volunteer will have to report their time spent behind screens and hours sleep daily, with screenshots of their results. The data required was easily gathered thanks to a feature provided by iPhones called Screen Time, and every person involved in the experiment keeping track of their sleep time thanks to the help of an Apple Watch. The experiment involved 10 test subjects, which had to report the daily results for 2 weeks. The subjects were told to work under normal circumstances for the first week, so the results were completely natural. For the second week, the test subjects were asked to reduce their screen time as much as they could, without compromising their activities and tasks required for the day. So these are the results of the subjects. As you can see, in each table, it says which day is it, and the characteristics of each subject, such as their age, their gender, how much time they were in front of a screen in that day, and hours slept. The first table shows an average of week 1 with the average of each subject, and week 2 has the average of each subject. And at the bottom, there are two graphs. The left one is from week 1 and the right one is from week 2. You can see that in week 1, the line that represents hours slept is more under the line of week 2. So that means that in week 2, they slept more, and also the dots are more to the right in week 1. So that means that in week 2, there was less time in front of a screen. As the screen time increased, the hours of sleep decreased. The line is much lower and more inclined in graph 1 than the one in graph 2, which visually represents that graph 1, which showcases the normal week, shows a major decrease in hours slept, compared to graph 2, which showcases the week where they reduce their screen time. That shows a much more moderate, but still present, decrease in hours slept. The purpose of this experiment was to see the effect of blue light on sleep quality, or in this case, hours of sleep. Graphs showed that the increase in blue light exposure leads to less hours of sleep. We weren't able to measure the hours of both blue light exposure and sleep in an exact way. We relied purely on the data given to us by some functions of Apple devices. We could have someone measuring or counting the time for every person daily. For future experiments, we could see how exposure to blue light at different times of the day affected productivity and overall daily activities. These are the references we used. I hope you found this research useful and interesting. Thank you.